This is Erasmo. He is doing linear algebra homework whilst eating a bag of chips. And so, as you can see, his room is a complete mess. He's a very disorganized person. He's throwing chips. And basically, he forgot to take his insulin and passed out. And this is a big, big no-no. And there's the insulin. Thank you. Hey there. Is your name Erasmo? How old are you?
20?
Yeah. We found you knocked out in your dorm, and your roommate was fortunate enough to find you. You forgot to take your insulin. You're a type 1 diabetic. This is not the first time. I think we're going to have to recommend you to a colleague of mine, Dr. Brian Torres. He's an endocrinologist. I think there's another device that you can use to get your insulin on time, because you've been missing all of your shots.
Hello, you must be Erasmo. I'm Dr. Brian Torres. So, I heard that you passed out. Tell me more about what happened.
I was doing some linear algebra homework and just kind of got super tired and fell asleep out of nowhere. Guess I forgot to take my insulin.
Yes, that's a big problem. You've been missing your insulin shots. Tell me what's been going on with that.
It's just something that gets out of mind sometimes, and I completely forget, and I don't know, I'm really looking for something that's a little bit more automatic so I don't have to be constantly thinking about it.
Alright, well, because you've been missing your insulin shots lately, how about I introduce you to continuous glucose monitoring? And hopefully this system will allow you to take your insulin without really having to think about it. How does that sound?
Sounds good, but since I am an engineer, I'm very curious about the different maths involved with this. Like, how does this system work?
So the way that continuous glucose monitoring works is that it takes the values of your carbohydrate intake, your liver function, and your insulin levels, and it stores them into 6 different matrices. Now, 3 of these matrices are going to be a coefficient matrix, while 3 of these matrices are going to be a parameter matrix. These values are then recycled into this function, where this phi is calculated in respect to the liver function and the insulin levels. We can then take the array of the parameters, which is given by this, and we can also take the array of the coefficients, which we calculated here, and we can take phi, and then we can take the product of these 3 values with respect to both the carbohydrate intake, the liver function, and the insulin levels, and we can take that product with respect to the carbohydrates minus that product with respect to the insulin levels plus that product in respect to the liver function, and then we can take that and that'll form a glucose function. We can then take that glucose function and we can put it into this normed vector space, and we can take the glucose function minus the blood sugar measurement, and then that is the equivalent of this summation of the glucose function minus the blood sugar measurement squared. So using this function, we can calculate or predict when potentially your glucose will go up. Do you understand what I mean?
Well, I honestly think that it's a little bit too complicated, and think you could actually just take this matrix such that A and X are being the coefficient of the parameter, where we then get the transverse of X to make vector multiplication work, because right now we have an n by 2 and an n by 2, but if we get the transverse of this one, it becomes a 2 by n. So then our resulting matrix would be an m by n. So that could be represented by I and j, where our coefficients are now our rows and our parameter is now our columns. So then if we get this time matrix, which we can calculate by getting this, where we get the time times the rows and the columns transversed minus the time with the columns minus the kernel function of the time. We can then, and by kernel function I mean this phi value in terms of this time matrix. So then we can get W dot product of the kernel function such that time matrix will then give us a blood response value for a given parameter. And this can then go back into here, which then greatly simplifies all this computation, which can be simply done on MATLAB.
Wow, that's very interesting. This is a good research topic, isn't it? All of this math is miraculously done by this tiny device.
All that math inside that little box.
Amazingly, right? We've come a long way as medical providers. So, is it a deal?
Seems like pretty easy. Sounds great.
I don't get it. I feel like we should do the real one first so that we can actually. Let's do the Family Guy thing.
What Family Guy thing?
Okay. Just keep recording, okay?
Okay.
Hello, I'm Brian Torres. I'm a doc. Again, I can't believe I did it again. Alright. Was that good? Was that bad? That was pretty bad. Wasn't it?
Are you being serious right now?
I'm being serious? I have.
Is that the Family Guy thing or what?
No. Hello. Hi, I'm Dr. Bobby Baker. How's it going? Hello. Hi. Hello there. This is done so that we get the so that we can get the bloopers later. All right. Hi. Nice to meet. I did it again.